All right, IBAASL2. We are pretty much finishing off Chapter 7 today. I know it was a quickie, but we're really just going to talk about a couple little applications of finding a line of best fit using a graphing calculator. So I've seen it come up on IB exams where sometimes they ask you to find like a y on x regression line or an x on y regression line. We're going to talk about how you find both of them and why you would want to use one over the other. So first of all, the y on x. This is another way of saying like a y equals something with x in it, where x is the input and y is the output. So this is the input, this is the output. So you can think of it as like y on x is like y equals something with x. The advantage of using a y on x is that it allows you to get a y given an x. So if they're going to give you some sort of x and try to get a y, you would want to use the y on x regression line. The flip of that is the x on y. Now remember, this means that the x is going to be the output and the y will be the input of the function. So that looks something like this: x equals c plus dy. Oh, also I realize like you guys are used to y equals mx plus b. It's still the same thing. It's like y equals mx plus b, but now it's like the b is in front and the b and the a switch places. So it's still like this is your y-intercept. And this is still your slope or your gradient. I'll be good. I'll use the British gradient. I'll also be good by putting slope in parentheses. So sometimes if you get the x on y, that allows you to estimate an x given a y. So if you're going to be inputting a y, you can use the second equation. But they're both just versions of the same thing. They're both just algebraic reworkings. But I'm going to show you a couple tricks on your calculator to be able to find both of them. One quick note. Whoa, excuse me. No matter which one you pick, the Pearson's correlation coefficient will still be the same number. So it'll still tell you how strong your model is by how clustered the data is around a linear line, whether you do y on x or x on y. Here's our one example we're going to do today. The scores marked out of 10 for a class of students in English and TOK. For anybody who's not familiar with TOK, this is an IB class called Theory of Knowledge. Use technology to help you find the regression equation of y on x. So remember, y on x equals y equals a plus bx. The way you're going to do that is you're going to take this top set of data and we're going to punch it in for L1. It's a terrible L. L1. And then the bottom set of data we're going to punch into L2. Now, I showed you guys in my last video how to find lin reg on a calculator, but just a quick review. Once you have L1 and L2 punched in, then you go to Stat, Calc, linreg, and then it says, let me see the actual wording, AX plus B. Man, they're just flipping letters everywhere. So that's the one that you want. Punch that all in, do it up, you get y equals 1.92, which is the y-intercept, plus 0.764x. Now, to find, so that was just all straightforward, finding the regression equation, the line of best fit for y on x. If we're going to find x on y, it's the flip of that. So here's how you do that. You still keep the English in L1 and the theory of knowledge in L2, but you want to reverse your inputs in your lin reg. The way you do that is you run lin reg the same way that you would right here. So hit stat, calc, lin reg. But then if you're on an 84, there's that menu where it says X list is something and Y list is something. What you're going to want to do is put the X list as L2 and the Y list as L1. So use those L1 and L2 buttons that are down above the 1 and 2. This is essentially flipping your inputs and outputs, and it's going to give you a y equals mx plus b again, but now it's not going to be a y equals mx plus b, it's going to be an x equals, gosh, that breaks my brain, x equals my plus b. It's going to be an x on y equation. So when you do that, you get x is equal to 1.39 plus 0.902y. So you're still using ln-reg, but you just flip the list 1 and list 2 as the inputs and outputs, and then that will give you an x on y equation instead of a y on x equation. Part C. Show both lines on a scatter plot with an English score on the horizontal axis. So, English scores were the x's, the horizontal axis. That means we just need to make a regular graph of this. The way you can come up with this graph is to get data in L1 and L2. Then you hit second stat plot. The stat plot button is right above the y equals button. And then once you're in there, you need to go into plot 1. And then highlight on and hit enter. Then to be able to see the nice stat plot of it, you hit zoom, and then arrow down to zoom stat. It's like another number 9 or something. Then that'll show you a nice scatter plot of the L1 and L2 that you punched in. To be able to see these two lines right here, you're going to have to take these two equations and then hit y equals, and then punch them into y1 and y2. Then you'll be able to see those two regression lines on the data. Part D says find the predicted TOK score to the nearest whole number for a student who scores 9 in English. So for part D, they're giving you an English score and they want to know a TOK score. English is the X input, TOK is the Y output. So they're saying, like, given an English, what's the TOK? That means that you should use the Y on X equation because that takes an input of English and outputs a TOK. Here's our Y on X equation, 1.92 plus 0.764x. So for part D, y equals 1.92, 0.764x. And we had to punch in a score of 9 in English. So we just say y is equal to 1.92 plus 0.764 times 9. When you do that, you get 9. And this is rounded to the nearest whole number because the original scores on these tests were whole numbers. So if you get a score of English, or a 9 on English, you'll get a 9 on your TOK according to this model. Part E, party time, says find the predicted English score to the nearest whole number for a student who scores 8 in TOK. Now they're giving you a TOK score and asking you what the English is. So they're giving you a Y and asking what the X is, which means we need to use this equation right here, the X on Y. So the X on Y is, so this is part E. X is equal to 0.139 plus 0.902y. They're giving us a score of 8 for TOK. Remember, the Y's are the TOKs. So this will be X is equal to 0.139 plus 0.902 times 8. When you crunch that to the nearest score, you get 7 on English. Now, I know you might be looking at this and being like, it's kind of silly to come up with 2 equations. Can't you just do the one y equals mx plus b for this? That's like, TOK equals something with x in it, which is the English score. And then if they give you an English score or a TOK score and you want to find the English score, you could just do some algebra to rearrange it. That is 100% true. You could do that. I just know in an IB testing situation that they might ask you to find these 2 models. So I want you guys to be comfortable with the calculator trick of flopping the L1 and the L2 so you can find either a y on x or an x on y. All right, you guys, that's all I got for us today. Happy studying. Please come ask me questions.